Good afternoon and good morning, everyone. Welcome to the Solutions at Scale webinar this afternoon. I appreciate everybody's attendance. Joining today, we'll have representatives from Pavilion, myself, Mike Tanner, and a representative from HeavyAI, Adam Edelman. Today, we'll be talking about solutions at scale. I'll talk a little bit about what we really mean by that. And then Adam will go in and discuss visualizing the problem of huge data and do some demonstrations in real time. And then following up at the end will be Costa Hasapopoulos, Field Technology Officer, talking about the conceptual technology overview. If you have any questions, please post them in the chat and we will review questions and provide answers at the end of the webinar. Again, thank you for joining today. With that, we'll move forward to the next slide. Total Solutions at Scale is a series of webinars that we're putting together to discuss real life and real-time solutions. These are solutions that have been put together recently with modern hardware and software technology that hadn't been available previously. The technology is being used in the federal government today with folks like the Department of Defense, Department of Homeland Security, and others. One customer quote that we actually have from a customer using these technologies that you've made the impossible possible. Things that they were not previously able to do, they can now do with this newer technology. The types of data that we're working with, just exponential growth in the marketplace, both the volume and the velocity of the data creation from all different types of formats. It's coming in different formats from different access methods. There's some examples on the screen here of the different types of data being captured. And sometimes the data as it comes in needs to be translated or transformed. And so we need technologies that can do that and work with multiple types of information and multiple types of data. Types of applications that are driving these use cases are artificial intelligence, machine learning associated with that, cyber solutions, working in virtual environments, doing things like facial recognition, and some of the analytics that we'll be reviewing and HeavyAI will be demonstrating today. And in the life sciences world as well, whether it's x-rays or things within the life sciences. So all different types of use cases in the marketplace. And with that, I'd like to hand it over to Adam to speak a little bit more about specific use cases and demonstrate those uses. Adam, I'll let you share your screen.
Great. Thank you so much. Appreciate that. I will share my screen here. I've got a couple slides and then actually want to get right into a demonstration since I think that's always more interesting to see something as opposed to talking about something. So again, I'm Adam Edelman, Federal CTO here at OmniSci. What was OmniSci now is Heavy.AI public sector. I'd say that's probably the biggest thing for folks who may have known us by our previous name. OmniSci is now Heavy.AI, and it really goes into a little bit about what we were just talking about here with we're looking to solve really big problems, heavy problems around data and analytics. And so if you go to either omnisci.com or now Heavy.AI, you'll see that rebranding. So that's been really exciting for us. In terms of what we're talking about here, it's again analytics at a massive scale, and we'll demonstrate that. All of that is built on super fast SQL. So the core of what we do at Heavy.AI is really fast SQL, and then on top of that, do interactive geospatial intel. And the way that we do that is through a hardware accelerated advanced analytics, specifically GPUs. So thanks to GPUs, some folks have probably heard of those before, right? You thought that was just for computer games or things like that. No, in fact, it's actually made a big leap into the enterprise space because essentially GPUs are just good at doing math very quickly, and doing analytics is really just doing math, right? Looking at a lot of data, what am I filtering on, what am I looking for, and then being able to draw pictures of what we're seeing. So that's what you'll see here today. I won't do too much of the product overview. Let's get into the demo first, and then we can kind of come back and dive into architecture. But I will put this slide up just to give you a sense of where this fits within the analytics space, just for folks who are curious before. So certainly you have tools that are very interactive, right? So you think of your desktop tools like Tableau and Click and Spotfire and Power BI, these type of things. And those tools are all great. But at a certain point, you put a few tens of millions of records into them, they're going to bog down, they're going to get slow, and that's just a limitation of the hardware there, right? What you'd find is as you get to looking at data at larger scales, traditionally folks had to move to these large data warehouses, things like Snowflake or BigQuery or Hadoop. Those are great for looking at really big sets of data, but they're not very interactive, right? It's not something you would put in front of a non-technical analyst to have them zoom around a map and look at tens of billions of things, right? And so what Heavy.AI is brought together is this ability to do data at scale, but also make it interactive. So enough talking. Let's actually take a look at it, right? So for folks who want to follow along at home here, I am on heavy.ai/demos. You can actually see we've got a whole bunch of interactive demos that we have on our website, everything from census to oil and gas, tweets, taxi rides, MBA shots, whole bunch of stuff here. I'm going to focus here on the shipping one. Go ahead and click on that. We're going to look here at AIS data. So for folks who are not familiar with what AIS is ship beacons, essentially. So every time a ship is in US waters over a certain size, it has to transmit its location on a regular interval. As you can imagine, this becomes a very large amount of data. And so in fact, if you take a look at the AIS set that we're looking at here, this is 2009 through mid 2015. So about 6.5 years worth of all pings in US waters. As you can imagine, that's probably a lot. And if you can see this blue number here, it's 11.4 billion with a B transmissions. So a pretty huge data set, right? Again, typically something that if you wanted to ask questions of that data, to say, show me pleasure craft in Southern Florida in 2011, you would probably have to structure a query and write that and then render that somehow, export that data and put it in some sort of rendering tool. What Heavy.AI allows you to do is interact with the same way that you would interact with any small or interactive data set, right? I can zoom into Southern Florida here. I can click on pleasure craft. I can say, just show me the ones for 2011, and then maybe I can even zoom in further to take a look at individual tracks, something that I might want to be interested in. What was this ship doing? It's got kind of a interesting weird track. And every time that I'm moving the mouse around, moving the map, clicking on a filter, changing any of these parameters, in the back end, it's just doing SQL, right? So it's querying a SQL database, getting a result back in a few milliseconds, and then drawing all those results on a map, right? So what powers that here is the hardware, right? So the GPUs, which allow us to do this rendering, and then of course also our good friends at Pavilion, who provide this ability to hold these massive amounts of data. So well, with that, that's how we're allowed to do, again, these types of things at scale. So I'll give you an example that's maybe a little bit different here. I'll just clear out all my filters and show you how some of our federal customers are using this more for their intelligence purposes. So I'll go here to Boston, and we'll do the same thing click on pleasure craft, just filter down to those. And so you'll notice our time chart looks very different now, right? And that is because, no surprise, no one goes sailing in Boston in the middle of winter. You know, I wouldn't want to either. But let's say I zoomed into that. Say, okay, well, let me zoom into those crazy folks who are going sailing in Boston. So I'll just choose some winter here. You can see now I've filtered down to just 10 ships. And what I might say is, you know, this is a pretty interesting set of individuals, right? Who are these crazy people who are going sailing? For intelligence purposes, you can imagine that this might be some other selector, right? There's a lot of reasons when we do intelligence work that we're very interested in a specific set of people or devices or vehicles or whatever it may be. But once we have that set that we're interested in, we're often very curious to know, okay, where did they come from and where did they go, right? Essentially, rewind and fast forward, right? Give me the ability to do that. And Heavy.AI allows you to do that with what we call cohorts. And again, cohorts are just things of interest. So for folks who are perhaps new to the AIS, MIMSI, MMSI is just it's a fancy name for a ship ID. So if I say, okay, you know, I'm interested in the ship IDs that I've pulled out here, these 10, I can give my cohort a name. I'm going to call it Crazy People in Boston, because what are they doing going sailing in the middle of winter? Do they not know how cold it is? So I'm going to set that as my cohort. And now what's going to happen when I zoom back out is you're going to see a very different map, because it's only going to be focused on those 10 ships of interest. And I could say, okay, you know, where exactly are they traveling besides Boston, right? Where are they coming from? Where are they going to? You know, if I was only interested in the period before 2011, you know, maybe I can filter down a little bit further. I can see there's definitely some activity around Southern Florida, which again, you know, no surprise. Hey, if I was in Boston in the winter and I had a boat, I'd probably want to take it to Florida here. Let's see, is this Miami or somewhere else? Maybe Fort Lauderdale. I think it's Fort Lauderdale. But anyway, this gives us a great ability to go in and say, okay, find something of interest by exploring a massive data set, which previously I would not be able to do, right? I'd have to use you know, very large scale tools, Hadoop, Snowflake, things like that, write queries and get results, and then have to search individually for these devices. What Heavy.AI allows us to do is put in front of analysts, put in front of end users, really massive data sets, which one, they didn't have access to, and then allow them to be able to explore them interactively. So that's really the power of what we're doing. I'm gonna show one more example. I know there might be some questions here, so please, I think, put them in the chat if you have them. But let me do one more example that's a very different example, just to give you a sense of what the tool can do. Again, we're very agnostic when it comes to the types of data. We're at the core of it a SQL database. So the kind of data that you would put into a database, that's sort of structured or maybe semi-structured data, right? We're very comfortable with all certain types. Here we're showing something very different. So this is some of the work that we've done with some of our commercial partners have done, especially assessing California wildfire risks. And there's a variety of companies, you know, power line companies, utilities, other folks who are, you know, risk assessment folks who are very interested in this type of information. And here what we're showing is the ability to bring in not necessarily very large sets of data, but a lot of different types of data, right? And so what we're looking at here is actually a lot, right? And so I'll kind of walk you through it. So one is looking at flame risk here. So that's sort of obvious to understand. There's, based on the type of terrain and rainfall, there is a level of flame risk that gets assessed for individual locations. And we're putting that together with the vulnerability of spaces. And so when we say vulnerability, what does that mean? Well, you can actually see we've got a vulnerability, kind of a breakdown here in the upper right-hand corner for folks who want to see a little bit more detail there. So it's based on things like socioeconomic status, disability, right? Folks who are disabled obviously have a tougher time getting out in case of a fire. Minority and language. Language tends to be a barrier for transmitting, especially life-saving info in event of an emergency situation. And then housing type, right? Whether there's no vehicles in the facility, crowded housing areas, things like that, which might make it difficult to evacuate from a potentially dangerous area. So putting that together is something that typically would be done, maybe on a small scale at a city level, but would be difficult to assess to say, okay, let me put together these really large sets of data and see where things fall for particular areas. So let me give you an example, because I know Oroville, California was certainly in the news last fire season, and show you what this looks like. Typically, again, this would be something that would be broken down at maybe a county level, right? Maybe city, but it would be something that would be pretty rare. What we're actually able to do here, again, by bringing in flame risk, and this comes from I believe it's the what is it, USGS, as I believe responsible for flame risk. I should say Census and some other organizations are related on the vulnerability score. So we're able to bring in flame risk at not even just a county or city level, but an individual block by block level to say, where am I seeing vulnerable spaces, again, coded here in purple and pink, as well as bringing in things like, where am I seeing high flame risks, right? And this is, again, based on terrain and rainfall, right? So if you have a development that sits next to a park, obviously that park is of high flame risk. And then in these pink lines here, we're also bringing in high transmission power lines, right? And so this is something where a planner can, again, without having to write a bunch of very complicated queries and package something together, explore dynamically to say, where might I see potential risks, right? Especially as fires are cropping up. They're certainly very random. They can happen anytime. We don't want something that requires us to not be interactive, right? We want something to be very interactive where folks can say, okay, here's the latest area of concern. What are the not even the necessary cities of concern, but down to the block by block level? What am I specifically interested? What should I be focusing on?
About that. So thank you, Adam. As you talk, that's just a massive amount of data. And one of the things that we've tested at Pavilion, and I'll talk about our technology a bit, is some joint testing that we did with, at the time, OmniSci, now HeavyAI, with scenarios like Adam just presented, was taking this data, loading it all up into GPUs and doing the analytics. Well, what happens when that data is more than what can fit on 4 NVMe drives that are inside that NVIDIA DGX? And what would be the impact of that? Is the theory is, if I have these fast NVMe drives inside my server, in this case a DGX, that should be the fastest performance I could possibly get. Well, we did a bunch of testing and said, let's take that same data and take it outside that server and put it inside of a Pavilion storage array and connect that using NVMe over Fabric, in this case, Rocky or the Ethernet. It works the same with InfiniBand, with RDMA. And what we showed was the OmniSci/HeavyAI application performed exactly the same. There was no, call it tax, to put this storage physically on a storage array over a network outside. But what was the benefit of that? Is one of the original customers that brought us together had a particular data set that they want to do analytics over. I believe it was like 3 years worth of data. That's all they could do today because of the capacity of what could be loaded on the systems today. But by leveraging an external storage array like Pavilion, they effectively got unlimited access to data. And in their use case, they wanted 30, they wanted 30 years worth of data. And so as we look through that, there is no tax for a system. And how do we do that at something like Pavilion? Is our system is a little bit of an architecture lesson here. It looks more like a network switch than it does a traditional storage array. What we're seeing on the screen is our top view on the right and our rear view on the left. And we're fundamentally built around a 6.1 terabit per second PCIe switch, an incredibly fast network switch that has all these PCIe lanes to every single one of up to 72 standard U.2 2.5-inch drives. They could be 30 terabyte drives. And if you were 30 terabyte drives times 72 drives, that's 2 petabytes of usable capacity. Of course, you had smaller drives that would be smaller capacity, but I'll talk in max capacity today. So 2 petabytes of usable capacity, and every one of those drives can talk full bandwidth over a non-blocking PCIe switch that connects to not 2 controllers like most storage arrays have today, but up to 20 independent storage controllers. So that network switch inside that PCIe network has endpoints of a whole bunch of drives and a whole bunch of storage controllers that can talk full bandwidth to each other. Well, you got to get data inside and outside that box, and you do that through what we call our line cards that house our controllers. Every one of those line cards on the right that have yellow and highlighted on the left of yellow is a card that has 2 independent controllers, own CPU, memory, and 2, in this case, 2 100 gig network ports. So every one of those cards has 4 100 gig Ethernet or InfiniBand ports. We actually have a card that has actually a single 200 gig InfiniBand port if that is required. And that effectively delivering 20 million IOPS and 2 petabytes of usable storage, all that packed into 4 rack units. And just to be clear, I didn't say 4 racks, I said 4 rack units, which means 6.9 inches of space. So the way we do that is because our architecture hardware is fundamentally different. We also have no concept of a cache, no concept of a tier. Every one of our controllers talks direct memory access to every one of those drives. Our host, like the box that is running that HeavyAI application, talks remote data memory access to every one of those drives. Through our controllers, through that PCIe switch into those drives, we write natively to every one of them. So what we like to say is our software that enables this whole solution can take unfair advantage of our hardware. That system could be leveraged as block, could be leveraged as file, or leveraged as object. In the case of HeavyAI, we are block storage to them, and they speak NVMe over Fabric to us. So really unrivaled performance density. So with that, Mike, I wanted to give a brief overview, but we'll open it up some questions and answers. Before I turn it back to you, Mike, is remember, if you wanted more information from Pavilion, reach out to us at info@pavilion.io, or you can always see our website at www.pavilion.io. So with that, Mike, there may be some questions in chat, and I'll turn it for you to be the MC.
Great, thank you, Costa. Really appreciate that. There are a couple questions. I think the first one's probably directed to Adam. Adam, is there a data limit to the HeavyAI application set, the amount of data that you can analyze, and give us an idea of the data size of the data sets that you are working with today?
Yeah, it's a great question. So there is no limit to data sizes, as long as you've got big Pavilion hardware, right? We've got plenty of capacity. But no, it is again, at the core of what we're doing, HeavyDB. It is a SQL engine. Actually, here I'm gonna share my screen, Mike, real quick. I'm gonna steal this back from you to show maybe an architecture diagram, because this might be helpful for purposes of answering this question. Again, based on what we were talking about before, HeavyDB here, that's the SQL engine. On top of that was the render engine, which does what GPUs are good at, just drawing pretty pictures on that map, and then immerse is what I demonstrated. That's our web interface that kind of brings it all together. But in terms of what you can put into it, it'd be like saying, do you have a limit for the size of any database? Well, no, as long as you have the hardware for it, it's not a problem.
Great. Thank you, Adam. Yeah, I think it's interesting if you look at one of the customers that we've worked with together, they were able to look at 1 year's worth of data, in a DGX, but they needed to look at 5, 10, even 20 years worth of data. And whenever they tried to do that, the application, the analytics just kind of choked because the bandwidth wasn't there. And then enabling it with Pavilion, they were able to look at those large data sets. So great. Costa, the question for you, can the Pavilion store both structured and unstructured data? What types of protocols does it support?
Yeah, it's a good questions. From storage types, we could be configured to be all block storage, all file storage, or all object storage, or some combination of those three. In the case of HeavyAI, we are block storage to them, of which we have multiple protocols in which you can talk block, file, or object. So I think that answers the question, Mike.
Yeah, I think that does. Thank you, Costa. Maybe both of you, Adam and Costa, working with other customers, what types of data problems have you encountered, or what type of use cases have you been involved in? Adam, we'll go to you first, and certainly you demonstrated the shipping lanes and wildfires, but are there other types of use cases that you've worked with customers on?
Yeah, I think the types of problems when we think about them, we've got an acronym that we use, and it's VAST. And I'll tell you what that stands for. The V stands for volume. So really big data sets. What's really big? Well, truthfully, really big is existing tools whenever they fail, right? And so that could be a lot of different things. I'd say for existing BI tools, right? That's probably in the tens to hundreds of millions. For GIS, it's probably less than that. It's hundreds of thousands sometimes. So again, that's a bit of a changing threshold, but typically the sizes that we work on, we're talking about billions of data points, sometimes tens of billions, but at the minimum, probably a few 100 million.
Okay, great. Thank you, Adam. Costa, yep. What about from Pavilion's perspective? Other types of use cases or environments that you've supported, been involved in?
Yeah, that's great. So if you think about what we do really, really well, is we do super high throughput and super high IOPS at really low latency. That's general. Let's drill into that. Now, whether that's block, file, or object, it's all the same, very high on each one of those. But what we see is one of the things that is incredibly unique for Pavilion is our write latency, okay? And so in our write throughput. So anything that needs super high speed ingest, right? So use cases like that could be, we'll talk a little bit more federal here, maybe things that are taking big pictures in the sky, or maybe listening to things, or high-speed ingest of sensor data. That's an incredible use case for us. Of which then once it's there, things like HeavyAI do analytics on it, right? The second use case maybe, again, speaking of federal, by the way, that same pictures and image changed the industry to be media and entertainment. The cameras are just different, right? And where they're located. Change that industry to healthcare. It just happens to be microscopes, or DNA sequencers, things like that have heavy ingest of data. Okay, I think the next piece, and we'll stick back to federal again, is just like HeavyAI is a database, more of a modern database, a GPU type databases. Databases can really appreciate low latency, especially transactional databases that are writing lots of information. So things like SQL Server, things like Oracle, things like Elastic, things like MongoDB, things like Cassandra, so things like OmniSci/HeavyAI, any databases, because they can appreciate, they need high performance read, high performance write, and can take advantage of very low latency. So summarize, whether it's block, file, or objects, things that need a lot of throughput, right? In that box for us block, it's 120 gigabytes a second read, 90 gigabytes a second write. for block, 78 for file for read, 56 for block. Super high performance, low latency. Hopefully that helps, Mike.
Super. Yeah, that's a great answer, Coach. So thank you for that. I think there's one last question here that I think I can actually field this one. The question was, are these solutions US based and supported out of the US? And for that, both companies are headquartered in California, have support staff there in California. And I know both companies have some cleared resources as well to support the federal government classified customers. So with that, I want to thank everybody for attending today. As far as any follow-up, please feel free to reach out to us at info@pavilion.io. And Adam, what's the best way to reach HeavyAI?
Yeah, I'd say the best way to reach us, if you send a note to federal@heavy.ai, that goes to the whole team. Or you can reach me individually, adam.edelman@heavy.ai.
Great, thank you, Adam. And for those from a Pavilion perspective, I'm also reachable directly at michael.tanner@pavilion.io. Again, thank you everybody for attending today. Really appreciate you taking your time to meet with us and look forward to the opportunity to work with you in the future. Thank you very much. Have a great day.